rotor current frequency. The frequency of a voltage or current induced due to relative speed between winding and a magnetic field is given by the general formula. So like this. So frequency is equal to P divided by 120. Am I right? Ns is equal to 120 by P. Okay, synchronous speed is equal to 120 by P. From that formula, so frequency is equal to N into P divided by 120. Am I right? N is called relative speed between magnetic field and winding. N is called relative speed between magnetic field and winding. Okay. My winding means winding is stator now. Winding means stator winding. The relative speed between the magnetic field and winding. The winding is and stator winding is stationary, and the relay and magnetic field is rotating. What is the relative speed between? Tell me what is the relative speed between stator and stator rotating magnetic field? Is called N. Okay, synchronous speed. Because of stator winding is stationary, is not rotating, but magnetic field is rotating with a speed of ns. In stator, okay, stator magnetic field is rotating at a speed of ns, but stator winding is stationary. So what is the relative speed between these two? Ns minus 0. Because of the winding, that is called stator winding is speed is 0, but the stator rotating magnetic field is speed ns. Okay, so the n is called a relative speed between magnetic field and the stator winding, and p is called number of poles. P is called number of poles. Okay, for a rotor speed n, the relative speed between the rotating magnetic field and the rotor is ns minus n. Am I right or not? The rotor is rotating at a speed of n. The rotor is rotating at a speed of n, and stator is magnetic field is rotating n. Okay, stator rotating magnetic field is ns, stator rotating magnetic field is ns, and the rotor speed is n. Then what is the relative speed between these two? Ns minus n. Stator rotating magnetic field is ns, and the rotor is rotating at n. Then relative speed between nothing but ns minus n, because of these two are rotating in the same direction. Okay, these two are rotating in same direction. That's why the relative speed between these two is nothing but ns minus n. Understood? For example, if the rotor is rotating in one direction and stator rotating magnetic field is in another direction. But for example, stator rotating magnetic field is clockwise direction. Ns, that is called stator rotating magnetic field, ns in clockwise direction. Okay, and rotors rotating in anti-clockwise direction. Then what is the relative speed between these two? Ns plus n. Understood? Because of these two are opposite rotation. Okay, if the stator rotating magnetic field is ns is rotating clockwise direction and the rotor is rotating in counterclockwise direction. So one is rotating clockwise and rotor is rotating counterclockwise direction. Then what is the relative speed between? Addition, ns plus n. But here, actually, in this the stator rotating magnetic field is rotating clockwise direction, and rotor is also rotating clockwise direction. What is the relative speed between these two? Ns minus n. Because why? Because minus means if these two fields are this field, stator rotating magnetic field and rotor rotating in same direction. That's why ns minus n. Consequently, the rotor current frequency f is given by f is equal to ns minus n divided by 120 into p. You know, slip is equal ns minus n divided by ns. F is equal ns by this. You know the relations, and then ns minus n divided by ns minus n is nothing but slip times of ns. No? So s into ns into p divided by 120, and then that is equal to ns is equal, and then f is equal to ns into p divided by 120. So that is called s into f. So f dash is called rotor frequency, rotor current frequency f dash. Otherwise, sometimes some of the books notation takes f suffix r. Fr is equal to s times of fs. Fs is called f suffix s is called stator frequency, and fr is equal to slip times of the stator frequency. Understood? The rotor frequency is equal to this called f dash is called rotor frequency. The rotor current frequency is equal to the slip times of stator frequency f. Rotor frequency is equal to slip times of the stator frequency. Understood? F dash is equal to s into f. So rotor stator frequency is nothing but supply frequency. Am I right? Stator frequency is nothing but supply frequency. So we are giving the power supply to the stator winding directly. We are giving the stator supply power supply to the stator winding. Am I right? That means three-phase supply or single-phase supply. We are giving the three-phase supply or single-phase supply to the stator winding only. That's why stator frequency is called supply frequency only. Generally 50 Hz. But rotor frequency is changing. But rotor frequency is called slip times of the stator frequency. Understood? So the rotor frequency is not fixed according to the slip. The rotor frequency changes. Understood? The rotor current frequency is equal to the fractional slip into supply frequency. Understood? When the rotor is at standstill, when the rotor is at standstill means stationary. The rotor is not rotating. The speed of the rotor is equal to 0. The speed of the rotor is equal to 0 means slip is equal to 1. S is equal to ns minus n divided by ns. Here rotor speed is equal to 0. N is equal to 0. Then s is equal to 1. Then s is equal to 1. Then frequency of the rotor current is same as the supply frequency. That is equal to f dash is equal to sf. That is equal to 1 times of f dash is equal to f. At starting condition, what is the rotor frequency? Same as supply frequency. For example, the stator supply frequency is equal to 50 Hz. Then at starting condition, what is the rotor frequency? It's equal to 50 Hz. Understood? At starting condition, this rotor frequency is the same. It is not changing because of slip is equal to 1. When rotor is at standstill or stationary, that is equal to slip is equal to 1. If the frequency of the rotor current is same as that of the supply frequency, f dash is equal to sf. That is called 1 into f. So that is equal to f dash is equal to f. That is called rotor frequency is equal to stator frequency. Understood? As the rotor picks up speed, okay, the relative speed between rotating flux and the rotor decreases. The relative speed between the rotating flux, that is called stator rotating magnetic field, and the rotor decreasing. That is called ns minus n is decreasing. Okay, the relative speed between stator rotating magnetic field and rotor is decreasing. At starting, the relative speed is maximum because of rotor is stationary. Rotor is stationary because of it is having some inertia. That's why the rotor is not rotating immediately. After certain time, it is reaches to synchronous speed, but not synchronous exactly. Am I right? So that means the relative speed is decreasing. Understood? Consequently, the slip s and hence the rotor current frequency decreases. F dash is equal to s times of it. Understood? Like this, the rotor frequency changes. This is called rotor current frequency of this induction motor. Understood?